at large language model attacks, in particular 107 here. So we put in SecML. This is a different machine learning library than the one we've used in a lot of the previous projects because this has security features like attacks. And then I'll get a data set. This is going to be a simple data set with 3 groups of points, and the task is to just separate them into categories. So it's an artificial, simple task to see how poisoning works. So when that first one is done, which it is, I can run this one. All right. Okay. So there we are, 3 groups of points, and they overlap. And the goal is to separate them into colors. All right, by using location. And we're going to use support vector machines, which we talked about before. If you have trying to separate the red from the green, either of these lines will have 100% success rate. But in support vector machines, you use this one. You use the line with the largest width. So that would be the best, the red line would be the best line to separate these two. That's how you make a support vector machine. And as I mentioned before, almost anything is a straight line if you plot it on paper that is screwy enough, like log paper or paper with the square or the cube of the number. So we're going to create a support vector machine model to separate them. And that's here. The support vector machine here, and it's going to fit it. All right. And it's going to, the accuracy on the test set is 98%. It's used, I separated the data into a training and test set, and here's the results visualized. Remember, support vector machines are very fast to calculate because they only depend on a few points on the edge. So there's the regions. These are the boundaries, and as you can see, it's done pretty well, but it did have trouble discriminating the red from the green because they overlap, so it can't get it perfectly. So that's 98.8% accuracy. Now we're going to do an evasion attack. Evasion attacks are probably the most common, and because you have a model that's already been trained on test data, on training data that you can't control, and you're going to make malicious test data. So this thing was trained to discriminate animals. If we can determine this is a panda with 57% confidence, but when you add a tiny bit of noise, so it looks exactly the same to a human, it's now a gibbon with 99% confidence. So you carefully choose dots that will confuse the model, even though they would not confuse a human. And in order to do that, you have to know the weights of the model, but that's public information. You know, the models, in order to run the model, you have to have all the weights. So that's typically not a secret. And you can calculate from the weights which pixels it's using to do the job and go modify just those pixels. So here's an evasion attack. Now in this case, we're not doing image recognition, we're separating dots. So the evasion attack will move we'll move a point and move it to a value that causes the model to misidentify it. So let me get here. All right, there we go. And that's what this security machine learning model, library can do. It can calculate what motion would change it. So if you move this red dot up to here, it'll cause the model to misidentify. Now I think this might actually be poisoning training data. Let's see. We'll start from the test set element 5. We'll move it to a value that causes the model to misidentify it. All right. Now we run a test to see how much the performance of the model degrades. So this shows you a graph of how sensitive the model is to errors in the test set. All right, it's taking longer than I want to wait. I'm just going to look at the pictures. Here's what you have. Here's the accuracy of the model, and you can move it some distance, but after a while it starts getting it wrong and it starts getting it really wrong, so you gauge to chance after it's been moved enough. So that's one measure of some kind of evasion. Now it's a little, all right, so that's There's various modifications of this you can try, but that's kind of abstract. Let me go to the next one, which is much easier to understand because it's easier to see what's going on. So I'm going to stop this one.